Okay.
Chris, why don't you kick it off and take it through the note well, and I'll just do the drafts. Sound good?
Yeah, sounds good. Yeah, let me find my control. Come on. Okay. I lost the window that was controlling.
Oh.
So I lost the window.
Which window?
It's good, the sharing window. Is it?
Yeah.
Yeah, but I don't think I'm controlling. I am.
Yeah.
Okay, I got it. It's working.
Yeah.
All right. Thank you. Okay, I found it finally. Hello, this is LSR Working Group, IETF116. And we're going to start off with working group status. Here's the note well. Basically, it says if you participate, you're agreeing to the processes and policies. And then it lists a bunch of documents you can look at to find what that means. Okay. AC, you want to take over?
Sure. Can you move it for me?
Can I what?
Advance the slides for me when I need them?
Yeah, I can do that. I'm sorry. I should have
Okay,
shared it to
okay,
you,
great.
shouldn't I have?
Yeah,
okay.
so most of these were already on IETF, at IETF 15, they were already on the RFs. First of all, good morning, everyone, and welcome to Tokyo. I'm sorry I'm not there. Most of these drafts here were already on the RFC queue at IETF 115, but now they've all become RFCs. Couple of, it's good we got the IGP Flex algorithm because that was the basis for a lot of the other working group documents we have now. Next slide. And we finished up, in addition to those that were on the RFC editor queue, we also did a couple of OSPF maintenance drafts, the bidirectional forwarding, the BFD detection, and the advertising link bundle members in OSPF. Finish those up as well. Next slide. This is on the RFC queue now. It should be published shortly. This is an experimental draft that allows you to basically do loosely what a BGP route reflector would do with flooding in an ISIS network. And it's experimental because it's a little bit, it's radical. We'll see what kind of experience we get and how far that goes. Next slide. All these drafts have completed last call. We're waiting on review. It'll be good to get the OSPF v3 SR extensions to match the ISIS ones, so we'll have them both done. OSPF terminology, that's just getting rid of the use of master and slave, replacing it with leader and follower. that's done too. So vendors will be able to update all their documentation. Actually, I think they could now. You can update your show commands and things like that. I haven't looked, but I don't think there's anything in the Yang model. I'll have to take a look at that. We're doing some corrections here on, there were some corrections we did on the application specific attributes. Those are also done. Some clarifications that we found, I believe we found those clarifications, couldn't correct them with an errata, so we did a quick respin of these two drafts and got them through the working group in record time. Next slides.
Yeah, and just
finally,
I guess
the last one, IP flex algorithms. I should have said, it should say IGP IP flex algorithms. We made some changes for OSPF v3. We're using the NU bit in the locator for the flex algorithm for the unicast. That's no unicast bit to indicate that the connectivity that is advertised is relegated to the algorithm being advertised in the algorithm TLV. That was a change that we went through 2 last calls to agree on this. Next slide.
1 second. I was going to just make a comment. I don't remember if this discussion happened just between the chairs and the AD or if it happened on the list, but the 2 BIS drafts on there might in the past have been erratas. And they basically,
Yes.
John or somebody basically said the IESG wants to try to do these more as BIS drafts and just get them pushed through quickly. So this was a sort of test case for that. And it seemed to work okay.
Yeah, that's a good point. Yep. I think it did. I think
Okay.
it worked excellent. It went.
Go ahead.
And we got this experimental draft again. This was we back, I think 2 years back, we had a lot of energy put forth on flooding, improving flooding in IGP topologies where they're real dense, like data centers where you have a lot of leaf and spine, lots of ECMP paths between the routers and everything. And there's a lot of work done on this. It's kind of a major change to do flooding on a small, on a subset of the routing topology and just subsetting it. So we made it experimental status. The only thing we got left on this is the IANA considerations need to be updated to take into account what bits are and are not, what link specific attribute bits are and aren't applicable to link bundle members. Next slide. We got these drafts, these 2 Yang drafts. Would probably the 2 SR Yang drafts. Actually, I got some comments from Dibakar and Bhaskaran on aligning them, where there were some differences between OSPF-SR and ISIS-FSR, and the offers, of which I'm one. We're gonna look at doing making sure that they are aligned and identical for the capabilities, for the SR capabilities. The fast flooding is covered today. Next slide. More Yang. We'd like to get this extended LSAs because a lot of the other Yang models that are SRv6 related for the OSPF piece, OSPF v3 piece, they need these extensions in order to be completed because they're based on the extended LSAs. Next slide. And let's see if we have all these Yang models that are lower priority. And also like, for instance, the OSPF SRv6, it would be dependent on the extended LSA Yang model extensions. Next slide. Yeah, these are at least the flex algorithm ones. they're not a high priority, but hopefully we'll get to them in working group last column. And finally, do I have any more? Was that last slide? I think it was. Oh, I guess I got some more.
Didn't we,
Sorry.
didn't we just do
Chris,
last
yeah,
call?
sorry, I missed that. Yeah.
No, that's okay.
We recently, working group last called area proxy, didn't we?
Yeah, I think it was targeted at this Sunday. So I think yesterday it ended.
It did end. Okay.
So that I don't remember getting any objections to that. That's experimental. So we'll probably do
Right.
the write-up
Experimental
and
as well. Yep.
request publication.
Sounds good.
Okay. I think that's the last one. Let me see.
That's it.
Yeah, that's it. Any comments from the room? Complaints? Speed it up, guys. Slow it down. Okay, let's move to the next. All right, here we go. Oh, I know what I need. So flooding speed, Bruno. I'll present, I guess I'll run it for you since you're up there. Share. Okay. That's a little sheet. You probably twist the, yeah. Did you know that? There's a switch on top. Pull it towards you.
Hello. Okay. Good morning, everyone. This is an update on ISS fast flooding. Next slide, please. So just a short recap on the goals. We want to improve the rate of exchanging LSPs between adjacent neighbors. So we want to sync LSDB faster and still reliably. How do we propose to do that? To get rid of fixed timers and fixed parameters, which tend to be never updated over time. And we adapt to the speed of the neighbors, and thanks to flow control and congestion control. Next slide, please. So the contribution of the draft, and mostly on the receiver side, it is the signaling of flooding parameters. It's defined in section 4 of the draft. We have a flooding parameters TLV, which can be sent in LO or PSNP. And we also have an improved behavior on the receiver side. First is to acknowledge the LSPs faster on point-to-point. This is described in section 5.1. The goal is to be able to provide a faster feedback loop to the sender to adapt faster to the capability of the receiver. And second, we kind of define a packet prioritization in section 5.2. I don't think it's really new, but this is the opportunity to write it. So just in short, LO are more important than NSP, which are more important than LSP. Next slide, please. Now on the sender side, the draft proposed 2 congestion control algorithms in section 6, but the sender can choose another one. And that's because the extension defined section 4 and 5 are generic, and they are designed to support a different sender-side algorithm. Next. So what are the changes since working group adoption? So between version 0 and version 2, we updated the INI section with the code point, which is TLV21. And we also added a new sub-TLV to specifically advertise the receive window. And next slide, please. And between version 2 and version 3, we added a note, saying that the DIS plays a special role in flooding. So you may want to increase the priority of fast flooders. So a small optimization. Also a note to say that the draft focus on point-to-point links We also added a new section on LSP pacing. It's inspired, if not a copy-paste, from RFC 9002, which is a quick congestion control. And speaking of RFC 9002, we did some editorial changes to actually replace some word on sentences that we had by word on sentences from RFC 9002. Which presumably is better in terms of editorial. Next, please. In terms of status, the draft is stable. We have two implementations. For one implementation, we provided performance results in the interim following IETF 111. And we believe the draft is ready for last code, working with last code. Any comment or questions?
Okay, for people in the room, anyone object to doing a working group last call? No objections I've seen. So I think we agree too, so.
Okay, thank you.
Unless, IEC, I think you agree with that as well, right?
Yes, I agree. I'd like to encourage everyone to read I mean, as always, but in this case too, I'd like to encourage everyone, even if you've read it before, I know that this draft generated a lot of excitement back when it was, back around like when we were doing the implementation report and IETF 111 and everything. But as you can see from this status, there's been some significant updates, and I'd like to encourage everyone. I'm going to do so myself. I'm going to read through it from the top again and really review it during the working group last call period.
Yeah, I admit I haven't read it since the 9002 improvements. That's got to be better, right? Because that's their bread and butter is congestion control. It's good to use their vocabulary. Okay, thanks.
I'm wondering if how that'll impact the implementations, if at all. Anyway, I guess it's internal. That part might be internal anyway, but.
Okay, so far easy. No cues, no arguments. Okay, the advertised offset. Also in room. Excellent. Is this you? Yeah. Yeah, you definitely can use a laser pointer. I think that'll become important with those virtual slides. I didn't understand that.
Anyway, I think this is okay. Can I start?
Yeah. Go ahead.
My name is Louis Chen from Juniper. This is the first time I present on site. So today talk about the IGB extension for advertising offset for the flex algorithm. Next slide. The problem statements. So it is the reason why this draft is to try to advertise the per flex algo adjacent set in a kind of efficient manner. So because you know that the flex algo today, the adjacency actually being shared by different algorithm. So therefore, if you want to advertise individual kind of adjacency set for each flex algorithm, it would take a lot of advertisements. So for example, if a node with 1,000 links, the kind of advertisement 10 bytes, it becomes 10K byte with 1,000 links. So in this case, I only advertise around 10 bytes or 12 bytes, the kind of size of the advertisement. It will save 1,000 times. So this is the recap of the problem statements. And in this draft, I also introduce a virtual flex algorithm. What does it mean is, So it's similar to the relationship of a VLAN and port. That means with a flex algorithm, once you calculate, you can derive other virtual flex algorithm which share the same CSPF calculations. So that means you don't need to have extra calculations for, the different virtual flex algorithm share the same topologies. You do it one time, and the result will be shared. This saves time in the control plane to do this. So the relationship is very similar to VLAN and port, that kind of relationships. And but the need is sometimes you need different the prefix set and the adjacent set for different purposes. Okay, although they share the same algo, right? Then you may want to do that way. So how to make it efficient? Also very efficient. Later on, I'll tell you about example. Is very efficient. If you want to do like this way, you just advertise around less than 30 bytes, then you can build a new one. Okay, so for example, this is the example here is for the algo 0, which that's a recap of the problems, right? So if you see that the adjacent set from 109, this router is 32, which represents this length, is always being shared by different flex algorithms. So if you have a kind of SRTE, which originated from the 106, this router, it will referencing adjacent set in this in this label stack. Okay, then I will. Next slide, please. Okay, so here introduce a new kind of advertisements called the advertising offset for the adjacent set or per algorithms. So what does it do actually is I just advertise the offsets. I don't advertise individual labels or index, but I just advertise the offsets. So each router, C109 router advertise this offset, it will automatically deduct the kind of the adjacent set, the algorithm adjacent set based on the offset plus the algo 0 number. So this is very, very easy. And then there's another field I add in this draft is the virtual flex algorithm. That means it will be a kind of base algorithm, for example, 129. Then you can have the virtual flex algorithm 600 or 601. Today, you don't have that kind of flex algorithm, okay? More than 255, okay? So you can have the 601, 600, 601, this kind of virtual flex algorithm sharing 129 flex algorithm, that kind of topologies, okay? Just one CSPF, you can have multiple. Next slide, please. Here's an example. I try to illustrate how the 109 can to advertise the information to the other guys. So 109, this router will try to advertise something information to the other routers in the network. Say 105, 106 in this diagram will actually receive the information and derive a number called 3032. If you compare the previous slide, algo 0 that slide, this from 32 becomes 2032. This 2032 becoming a kind of 109 understandable kind of labels, which is related to flex algo 129. The reason why when the kind of the labels being peeled off each of the stage, when 109 see the top label 2032, you understand this is flex algo 129, and it can take action on this one. For example, I have QoS policy. Okay, I need the policing. I want to put this packet into serving queues, right? Then I immediately make an action on that one. If I only have a 32, which is shared by all the flex algo, it would not work. So the job of this 109 is advertise some of the extensions, and the rest of the node here in this diagram were able to derive the figures, okay? 32 plus 2000, which is the offset. So regardless of how many links you have, it will derive, okay? Next slide. So the relationship of the virtual flex algorithm and then the algorithm itself, okay? For example, here is a 600 and 601. they share the same 129 kind of topologies. So the same matrix, so same kind of IGP, whatever kind of things, right? The CSPF, right? What kind of things, right? But in the implementation, they can in different kind of relationship can be parallel. That means they're all equal. Or they can be parent and child relationship, just like stacked VLAN. Okay, and then in here, these cases, you can apply HQoS, HQoS into this kind of cases. That means this may be 10 gig, each of them is 5 gigs, something like that for QoS, if you want it like this way. Or it's a mix between the two, parallel and this one. But this draft do not dictate or how you want to do this. It's just how to tell you how to label it. Okay, but how you actually make it your network, this kind of hierarchical kind of things depends on you, your network implementations. So it's just a labeling methods allows you to do so. But how actually it works in reality depends on network configurations. Next slide. So this is why at the same time for virtual fax algorithm, this kind of concept, we need to advertise the prefixes as well. Because right now, in the extensions, we only allow to advertise flex algo, which is up to 255. But how about over 255, 256 and onward, then how to advertise it? So we need a kind of format. So it's also based on the, this is the base algorithm. This is the virtual fax algorithm. For example, this is 600, this is 129. Then you can have a base algorithm to advertise to signal how this one relationship is. So this is why there's a few with algorithm and virtual fax algorithm. Okay, this one actually introduced not in the second, it's a O2 draft, but in the 00 draft, also see this few. This is planned actually long before. Next slide, please. So this is the example of how it calculates. So in the first column, you see there's algo 0. That means if a node, this is a node advertisement, okay? It will advertise its own prefixes, and actually for the adjacency as well, from interface 1 to interface 99 in the first column. So this is advertised, okay? For the fax algo 129, it will advertise extension, which is the offset is 2000 for the adjacent seats. And then, of course, this one is advertised as a standard, okay? This is its own prefixes. But then the rest here can be deducted. So every node in the network receiving this information, arrow 0, the first column, and second column, this one, the offset, it will automatically deduct the rest. So the rest is just like this: 32 plus 2000, 3032. 33 plus 2000, 2023. 34, it is not used in the fax algo 129 because of amine group or wherever, right? So it doesn't use that. So it will not applicable. And it will all the way to the last one, okay? 2130. This is automatic deduct. So for the next column is the virtual fax algorithm 600. So in here, we advertise only two, okay? So less than 30 bytes in this case. Okay, the offsets for the adjacency is 6,000. For the prefixes, also 6,000. Then you can see the prefixes, adjacencies, all automatically derived. So the saving is a lot because you just advertise 30 bytes. Here, you create a new virtual fax algorithm. And another 30 bytes, less than 30 bytes, you create another one. So the saving is a lot because number of interface is logged, then the saving is much more. You see, this is the only need to advertise in the blue side, or the yellow side is derived value. That means every router received its information will automatically derive all the seat required. These kind of adjacency prefixes will be automatically derived in this case. So saving is quite huge in this case. If the node has a lot more kind of fax algo, have more links, the saving is more. So this is the reason why this draft, I think, this is trying to solve. Okay. this is the end of this presentations. Any questions on that?
Yeah, so thank you, Luis. I think from my point of view, the requirement is really clear. In fact, we also have a draft which proposed the similar solution for SRv6. So it's
Who's
necessary.
talking? I didn't see anybody in the queue. Who's talking?
Yeah, this is Wei Chang from China Mobile, AC. Yeah.
Okay, you need to get in the queue.
Yeah,
Oh, okay.
you're supposed to do the on-site, like,
Oh, okay.
Oh, I didn't see, oh, sorry, I didn't see that he was in the camera. Okay, go ahead.
Okay, sorry. I think it's really necessary to reduce the advertisement load per node per link. If you want to use the Flex Algo in a large network. So I really support this draft. My question here is that the solution you provide is valid. Have you had the running code for the solution now?
Not yet actually, but I think it's quite simple. And I believe this one, depending on implementations, right? It may be compatible with the old router, which do not run this extension as well. If they, yeah, just don't, yeah.
Okay, thank you.
okay, let's go to AC. Did you go on site in the queue?
Oh, yeah.
Yeah, okay, good. Okay, good. Okay, AC, go ahead.
Yeah, AC Lindum, Laban. Hey, I read the draft and I didn't know what a virtual flex algorithm was at all. It doesn't explain it at all in the draft. Now I saw your slides and back on slide 6, I kind of understand what it is. And I think you got the wrong term there for it. It's not really a flex algorithm. It's just another level of hierarchy that you have that you're going to assign SIDs to, so you can do something that you're not specifying. I don't know what you call it, but I think calling it a virtual flex algorithm is the wrong thing because it has nothing to do with a flex algorithm. It's another level of hierarchy that you're not really specifying in the draft. You're saying you could use it for different things, and this whole thing about how they could be all equal or all, that's not in the encoding or anything. That's in the that's all implementation. I mean, that's on the node, right?
Yeah, I think the names can change, right? The concept is there because it's better to use a name easy for people to understand. So I use virtual flex algorithm, but of course the name can change. Yeah, there's nothing actually is can be changed. Right?
When you referred to VLAN, that kind of made me understand it a little bit better.
Yes.
So the V from VLAN, I
Yes,
was like,
that's right.
oh, okay, I see. Because
Yeah.
I didn't get it at first either.
This is why I use VLAN example because easier for people to understand, but it's not exactly VLAN because it's not hierarchical kind of strictly hierarchical relationship. They can be parallel relationship because actually I just want to have different treatment for the packets. If they share the same topologies, then I'm looking for different sets, right? And then I have different kind of treatment in that one.
I don't have a better one, right? I don't have a better suggestion right
Yeah,
now, but
same actually.
I'm sure on the list somebody will think of something.
Yes.
Anyway.
Yes, I agree. Actually, I'm not no problem actually changing the names. Yeah.
Okay, AC, should we move to Peter? Peter. You're up, Peter.
Here.
Hi, can you hear me?
Yes, we can hear you.
Hi. Hey, so I have a couple of comments. So first of all, I'm not sure how real the problem is. I'm not talking about the virtual flex algo, just about the regular flex algos. The problem would be relevant if we have a lot of flex algos on a lot of links. I'm not sure that is a realistic case because flex algo is not a VPN technology. Typically, the flex algo, the number of flex algos you would use would be a single-digit number. And then my question would be, do we really need two mechanisms to advertise the same thing just to save some bytes? I realistically don't see that as a need. And for the virtual flex algo, I agree with AC. This has nothing to do with the flex algo. Please change the name.
Yeah, let me comment on that one. Actually, if you look at today's router, single router board, actually, the line card is 48 ports. So in one router, we're talking about maybe at least 6 card, right? At least 6 card in next slot, right? With 40 port, right? You already have 240 interface in one box. It is possible.
Yeah.
And then if you have some VLANs, it may be thousands. So there is a substantial number. We do have customers actually running quite a number of interface at some aggregation layers. That would be a lot, actually.
Yeah, but that still you don't run out of the LSP space because of this. If you look at the link advertisement and there's a TE, how many attributes do you add? I mean, what is really the problem here? Are you referring to the problem of running out of the LSP space? Is that the problem? Well,
No,
I guess
I
we have a
think
solution for that.
the problem actually you want to have, I think you agree on that one is we need individual, adjacent seat for each flex algo links. I think you agree on that one, right?
Yes, yeah. And we have mechanism to
then-
advertise that.
The question actually is about the scale, right? So I think we can discuss offline because the scaling becoming a kind of reality check actually, right?
That would be nice to go on the list, right? Because we could get some real numbers.
Yes,
We could like have a better idea
Yeah.
that rather than, we're doing a little hand waving now, right? It's like,
Yes.
But typically we don't have two ways of doing the same thing. So unless this is a real problem, then I would not like to see two different ways of advertising that it's it for Flex Algo. Okay, thank you.
thanks, Peter. Feng?
Okay, this is Fang Gao from Zhongguo Laboratory in Beijing. I have a contradiction issues about the flex algorithm. It's about between the node balance of multiple algorithm instance and the protection just inside one algorithm instance. As I made such kind of situation about 3 years ago in a network design. And since the large network scale and the vast root accounts, so it needed to establish a minimum level SR policy for the service. So we turn to the flex algorithm to release the pressure of the capacity on both the control plane and the data plane. And as the topology in your diagram, it have 2 physical plane on the links, and it needs 3 flex algorithm instance for the service. The bandwidth, the delay, and the best effort. If as we just have a available algorithm of SPF until now, and if we take all these links in the topology of the 3 algorithm instance, it will maybe all choose the single plane, the same link, and without node balance. And if we just exclude one plane of the links in the topology, it will lose the protections inside one single instance. So I saw you introduce the virtual flex algorithm. Whether it's possible to resolve these kind of issues.
Okay, I hear your question is about load balancing, right? Load sharing.
Yeah.
Okay, this draft is not solving that trouble. The
okay.
reason why, just like VLAN, how to use a VLAN is not about
Okay.
load balancing. You must have 2 ports.
Okay.
Okay, 2 ports or 2 kind of different paths, you can do load balancing. So, for example, you have flex algo 128, 129, they do
Yeah.
load balancing. There will be 2 flex algo, but within each flex algo, how the course QoS can be enforced is about this draft kind of, try to solve. It will solve in the inside one flex algo, how you solve this kind of labeling and also the QoS as well, and also maybe the kind of a TRFA, right, like a cases, because if the label is shared label, like 32, then the TRFA will be using other kind of links, which is non-flex algo kind of links. So that's another issue. So it's mainly solving within one flex algorithm, QoS that portion, okay?
Okay, thank you, thank you.
Hi, Jason from Huawei. Yeah, I'm trying to understand the problem you want to solve. You want to increase the number of the flex algos to networks and support, or you want to support more links with one flex algo?
So maybe I hear your question is, okay, first of all, is solve the advertisement problem first, right? To scale down the advertisement required if there's a number of links, right?
The number of links.
I mean, because more links actually you would, I mean, if traditional one, each of the links which you advertise are new labels, right? If 1,000 links, then you advertise 1,000 times. So instead, I just advertise one time, just the offset, and the rest is deducted. That's the number one problem. The second problem actually is, in some cases, customer may want to have a single algo, okay, similar algo. They maybe have multiple algorithms, but maybe some cases, they would like to, within a kind of topologies, they want to subdivide it a different kind of, just like VLAN cases, right? Similar to VLAN cases, right? But if we want to save some resources in doing the CSPF, because you calculate one time, you will deduct the rest of the, the things. So this is the second purpose on this additional virtual flex algorithm in this draft, is try to save some kind of resources as well to, but then you still have some other plane at the same time, running like a VLAN in the same kind of topologies.
Yeah, if that is the purpose, I would say, I think I agree with IC and Peter. This is something different from the existing flex algo. This is a hierarchical infrastructure. Actually, we have a related draft presented several meetings ago. On the scalability, we can use a shared topology, a shared flex algo for multiple VTNs or NRPs. And it also introduced mechanism to solve the problem. If you have a lot of interfaces, the amount of the seeds can be saved by using a dedicated data plane identifier. So I will share the links to the draft.
Yes, please share the information. I can read through,
Okay,
and then we
thank
can
you.
comment. Thank you.
Okay, and Les, you're the final one in the queue. I had to close it.
You can hear me okay?
Yes.
Okay. So I can't help feeling that this draft has skipped a few steps. In terms of the SID allocation strategy, it's all fine from an academic point of view to want to make the encoding more efficient, but this has a dramatic effect on how operators provision their networks. And I don't know if you've actually talked to any operators, got any feedback as to whether they see this as something that is needed or is practical. And then, frankly, the virtual flex algo to me is something that needs a lot more discussion. You seem to have introduced something with a couple of sentences that needs, in my mind, a lot more detail. Anyways, that's my comments.
Yeah, I think for the first questions about the allocations, right? It actually is just like a block. I think I present in the 00 draft about how the allocation strategies, but actually it's not so difficult. For example, even if 100, right, of flex algo, you have 1,000 links, you just allocate a block of 100 times 1,000. This is 100K, which is within the limit of the label space today, 1 million label space, we're trying to best. So that is totally doable. So that's not a big trouble if you do the planning correctly in your software writing.
Okay, I think we got to go to the next presentation. Spent a lot of time. Yes, thank you. All right. Oh, is this going to be remote? Ah, okay, it is. Hang on. I'll put the slides to you. Oh, Chunzi Lee, right? Slide
Yeah,
schedule.
can you hear me?
Yeah, I'm trying to pass you the deck. Hang on one second. I don't know why it's not giving me a selection.
Yeah. Hello everyone. I'm Li Chenxi from Huawei. My topic is EasyT metric LAN extensions. Next slide, please.
You should be controlling, so if you hit your right arrow, it should move to the next slide.
Okay.
Try it. Yep, you got it.
Yeah. In certain networks, network performance criteria are becoming as critical to data path selection as other metrics. RFC 8570 describes how to distribute network performance information, such as link delay, delay variation, or link loss. But we cannot describe this information in LAN subnetworks. This draft provides the necessary easy extension to collect network performance information in LAN subnetworks. As shown in the diagram, on LANs, each router only advertises one adjacency to the DRS and doesn't advertise any other adjacency. But when we measure the TE metrics on, for example, router A, such as unidirectional link loss using TWAMP, the result only valid from interface A to interface B or from interface A to interface C. Well, the interface B is on the device on the route B, and the interface C is the interface of route C. In other words, for the same local interface, for example, in the interface A, we can measure more than one result. When we receive the packet from interface A, we can distinguish the packet from interface B or from interface C by different TWAMP sessions. So each router should advertise the TE metric for each of its neighbors. Here, we show the define of unidirectional link loss LAN sub-TLV to carry the unidirectional link loss in LAN subnetworks, for example. And the other sub-TLV we extended in LAN networks is similar to this sub-TLV. The format is shown here. It is similar to unidirectional link loss sub-TLV in RFC 8570. The type is to be defined, and the length is a constant value, 4 bytes. Here we define a field, neighbor system ID, to carry the real neighbor's system ID rather than the DRS, so that we can know the T metric carried by the sub-TLV is for which neighbor. The other fields are the same as defined in RFC 8570. The extension for the other T metrics, for example, link delay or delay variation, may be similar to this. In other words, we also add the neighbor system ID in their sub-TLV. Well, thank you, everyone. Any questions?
AC, you want to go first?
Yeah, one thing, you had a lot of those, I know the loss, maybe you could measure that point to point, but if you're going to do, you had a lot of other ones that included bandwidth. Now this is an actual LAN if it has a DIS and everything. It's not a point to point LAN. So why how are you going to do things like bandwidth on a shared media? That was the one question I had on the list. And the other was, I said, why didn't you if you're going to do TE, why didn't you just model it in the actual IGP in ISIS as a bunch of point-to-point links instead of modeling it one way in the protocol and another for TE?
Yeah. Well, I guess your question is why I want to extension the TLV and measure the T metric in LAN sub networks, right?
My question is, if you want to do TE in a LAN network, why don't you just model the LAN as multiple point-to-points?
Yeah, you mean the metric is only for point-to-point?
No, what he's saying, because I had the same point, right? That you're basically breaking down the LAN peer adjacencies and then treating them as, point to point to put attributes on them, right? So the routers already support treating an Ethernet as a point to point, right? Or a point to multi-point in the case of OSPF, I think. So if you just change how you're deploying the IGP itself, right? All the other stuff falls in place. You don't need any extensions.
And also, if you're going to do you're doing TE on a LAN, you got all these. You didn't mention them in the slides, but in the draft, you're doing all these things based on bandwidth. If it's a shared media, how can you be sure of all these bandwidth measurements?
Yeah, I know what you mean. Here I just extend the IS in ISIS, but later we may also extend the BGP LS protocol to for report these this sub TLV for to the NCE.
But wait, hang on. This is something that happens a lot. Just because a BGP, like they can't both justify each other's existence, right? Introducing something in the IGP and then introducing something in the LS and BGP LS to carry it doesn't. They both don't need to be there, right? They both can work if you just model the network as point-to-point links instead of LANs.
Yeah, I think the T metric, we can also use the T metric in LAN sub networks because we can measure these metrics using different TVAMP sessions.
Well, in any case, I think we should take this to the list probably. I think you got a hill to climb here to show why this new way to model a LAN as point-to-point TE connections, why we need it.
Yeah, TE is inherently between two routers. So why don't you just model the network as point-to-points because you're doing point-to-point TE rather than modeling it different and adding new encodings. Anyway.
Okay, thanks.
Okay, thank you.
Okay, I think it might be Peter with prefix, unreachable prefix. I'll get you the slides in a second, Peter.
Yeah, sure.
Actually, I think it's going to give you the list, and then you pick. Do you see that?
Oh, I see some numbers at the bottom of the screen. All right. Now, these are the previous slides.
It's not actually giving you the titles.
No. Okay, I closed the deck, which was current one. And now where do I find the?
Oh, so if I click that, it says a new deck has been shared, but it's not giving me the selection. So
Okay,
it's,
I think I have it now. Is this the one? No.
I liked it better when they gave me the list because I could
Yeah,
find
I
it.
know. All right.
There we
Is
go.
it? Can you? Here you go. All right.
Yep.
All right. So it's Peter Psenak from Cisco. I'm going to give an update on the unreachable prefix announcement draft. Let me start that we added 2 new co-authors, Shraddha from Juniper and Gunter from Nokia joined the draft. So this has been presented previously twice. The draft basically describes how to announce the prefix unreachability in IGPs. We are using the existing protocol mechanisms, and what is most important, this is a backward compatible solution. So what we added is that we signal the UPA origin, but we still rely on the prefix metric, which in ISIS being larger than the FE0000 or equal to LS infinity in OSPF v2 v3 to maintain the backward compatibility. Because handling of these metrics is clearly specified in the existing RFC, saying, you know, when you advertise this prefix, it should not be used for routing purposes. So the spec basically says that you can advertise and use this metric when you advertise for other purposes than building the normal routing table. And well, basically we are adding one of these purposes and we advertise it. It still allows us the UPA to be deployed incrementally because any router receiving such an advertisement would just not use it for routing. So, you know, we didn't have the origin signaling the UPA origin originally, but we got a feedback from the working group from several people that they would like to explicitly see that the reason why the UPA was originated was for the purpose of the unreachability. So, you know, we define 2 basically origins. One is being the loss of reachability due to unplanned, and the other one is due to planned event. It basically is using that or specifying that other purpose for which the prefix was advertised with the unreachable metric. The treatment of these flags on the receiver is optional, and we are not specifying what do we do with these flags. We are just informing the receivers this is why we generated this prefix with unreachable metric. And here are some of the mechanics. So in ISIS, we are using the extended reachability attribute flags defined in RFC 7794, where we define 2 flags, it's just 2 bits. And we say that the prefix which is advertised with these flags must have the metric set larger than the unreachable metric. In OSPF v2, we are using the OSPF v2 extended prefix TLV, where we have the flags field. We are defining again the 2 flags. And again, we are saying that if you use one of these flags, the metric must be set to LS infinity, otherwise you ignore these flags. A bit more complication for v3, we don't have the bits available, so what we define a new prefix attribute flag sub-TLV as a sub-TLV of the OSPF v3 TLVs defined in the RFC 8362. And they are part of the intra-area, inter-area, and external prefix TLV. The 2 bits are the same, and again, if advertised, the metric must be set to infinity. We also added a text in the draft which talks about the area partition. We clearly say that the UPI was not meant and is not meant to solve the area partition. It doesn't make it any worse. It can make it better in certain conditions, but this is not the purpose of the UPA draft. So the intended status originally was informational because we didn't add any encodings. Now with the new flags, I change it to the standard track. It's up to the working group to decide which way or which track to take, but I put it as a standard track now because of these additions. And the next steps, well, comments are obviously welcome. There seems to be sufficient interest to address the problem in the working group. There is implementation, at least one available. I know the other one is being worked on. And well, so I would think maybe this is a good time to take this to the working group.
Okay, just a quick comment before we get going. I've been told that there's a lot of side talk going on, and it's pretty annoying to people. So if you have a discussion to have with somebody, your neighbor or whatever, just go outside, because everybody wants to listen to who's talking mostly. Okay, Aijin.
Yeah, I'm from Taiwan Telecom. We are very glad to know the Peter have switched the solution to the explicit notification. As we all know, in last meeting, you have proposed the implicit single notification, and we have pointed out the implicit notification is insufficient. So we need the explicit singly. So I have discussed with Peter for the future conversion of these two proposals, and we are agreed to converge, but there are some different opinion for which draft should be the best line for the convergence. Here is our consideration for the future conversion. And you also mentioned that we are the first to present the problem, and also the explicit notification, single notification. Regarding expected single notification, there are other components that you have not covered. So we think we should forward the solution based on our proposal, and we are glad to invite the author from Peter to join us. Okay.
So I'll just make
I will introduce in more detail for our UPS solution later. And
yeah, you're presenting right. Yeah, next. So I'll just throw out a couple of things with the chair hat on. Once a document is adopted as a working group document, right? The working group owns it. So, I mean, eventually, the IETF is actually a pretty weird standards organization in that it puts people's names on the documents, right? So I'm not sure let's not get hung up on whose draft it is. I mean, generally speaking, when people merge, the author list merges too. And I mean, I guess that should be enough. We should just take whatever document is, closest to the solution that we want. I don't think we should get too hung up about which document starts. I don't know. I haven't really thought about it, but I thought this would be an issue, and it's already been brought up. Okay, so anyway, that's just, eventually we could have Ed. You can have a single editor as the top line author and no authors underneath. I mean, I don't think we're going to do that, but just keep that in mind. It's not actually owned by a person after it becomes adopted.
All right, just quick comment here. So going back to the technical stuff, there are technical differences between the two drafts, and that was the reason why the drafts are different. So maybe I can comment once this is presented, but I fully agree. I mean, which one is solely based on the proposed solution, not on, who wrote it or who started. So.
Okay, AC, I think you're up.
Okay, AC Lyndon Levin. First, I agree, speaking as co-chair, I agree with everything Chris said about the draft as being a work product of the working group and combination of authors. Now, as a technical comment, speaking as a working group participant specifically to this draft, one thing you might want to consider is for OSPF v3 using the no unicast bit like we did in IPFlex algorithm, then you'd have complete backward compatibility, which would be good for incremental deployment, where this would never, you could say that you'd never advertise this more specific prefix, and even if somebody didn't support this, they wouldn't use it. I don't know if maybe I didn't think of anything, but I thought maybe that would be a good thing. Then you'd be sure that for all three protocols, OSPF, ISIS, where you have the higher metric, that it's not going to be misinterpreted as a reachability. Unreachability is not going to be misinterpreted as reachability. For OSPF v2, you'd just be advertising it in the prefix attribute, not in the LSA, the opaque prefix extended attribute, and you wouldn't be advertising the prefix in the base LSAs. And for OSPF v3, the extended TL, with the OSPF v3 extendability with the TLVs, you would be setting the NU bit in the prefix, and then you'd be advertising these notification attributes that wouldn't be misinterpreted as reachability because the NU bit wouldn't be set. I know you understood me, Peter. I'm not sure anybody else did.
No, I understand. I mean, we can use whatever existing mechanisms we have to make sure that nobody interprets it as a reachable prefix. And
yes,
yeah, we can use a new bit.
And I think that would, and this is, again, I'm speaking as a working group member, and I think that would put of the two proposals, that would give this one a clear advantage.
All right, sure.
Okay, Les?
In between the signaling the planned event versus the unplanned event, it's not at all clear to me what the use case is for this. If you had a planned event and you were preparing for it, presumably you would have moved all traffic away from that destination before you actually took the node out of service. So it wouldn't matter whether you reacted to this or not. So could you clarify what the use case is for the distinguishing between the two types of events?
Right. So this particular use case has been brought by Shraddha. So I guess what you want to do is to distinguish between the planned and the unplanned, and how the receiver distinguish and treats these two events is something that we don't want to specify, but maybe Shraddha is the right person to give you the answer.
Okay, I'll look forward to that.
Well, Shraddha, you're in the queue. You can just talk since you were.
I guess Shraddha, you can go ahead and
You're
respond.
muted. Maybe you need to unmute.
Hello, can you hear me now?
We can now.
Yeah.
Yeah, so if it's a single domain, the planned and unplanned events, the way we differentiate the planned event is that we set it to overload and advertise high metrics so that traffic is moved away from that node. So the similar use case applied to multi-domain network wherein summarization is in place. So because of the summarization, the metric cannot, based on metric, you cannot move the traffic away from that node. So, this is sort of the event, the new bit indication that, it's a planned event is trying to mimic the same thing in a multi-domain network where summarization is in place, so that you indicate that this is about to go for a planned maintenance, so that you can then move the traffic away from that node, from the ingress.
Okay, Bruno?
Bruno Ducran, Orange. Can you go back to slide 4, please?
Yeah, sure.
Thank you. So first of all, thank you for the updated version and for adding flags to signal UPA explicitly. However, in this version of the draft, flags are informative, if not decorative. And I believe we would need an explicit advertisement. So to step back, I think we need three different signaling. First one is to advertise explicit advertisement of IP prefix. Let's call it state +1. We have that in ISIS from day one. Another state that we need is to advertise no reachability. We have that in ISIS from day one by signaling no reachability, or by signaling a prefix reachability with iMetric. Both have the same meaning. And now I think we need a third state, which is explicit unreachability, or UPA. So far, you signal that with max metric, which is the same signaling as no advertisement. So I think this can be an issue for backward compatibility, because we have the same signaling for two states.
So I don't understand, Bruno, honestly. We have the metric which says don't use it for routing. And the spec clearly says you can do this. And all we are saying is that the reason why we are doing this is because of the planned or unplanned event. Why do we need yet another state?
Because
you can advertise the unreachable metric for any reason. The treatment is defined. We are not introducing any other new treatment. All we are saying is, because you can originate the max metric for whatever reason, the spec doesn't specify. We are specifying the reason why we are doing it. That gives us sufficient information we need. We don't need any new state.
Yes,
I don't see the backward compatibility reason. I don't see a backward compatibility issue here.
Okay, today in my network, I can advertise a prefix with max metric. That doesn't mean unreachable.
It does.
That will not withdraw reachability.
Don't forget there's a delay, half a planet around.
Yeah, sorry. So in my opinion, the draft or the existing specs clearly say, if you advertise that specific metric, the prefix cannot be used for routing, right? It can be used for something else. And we are saying it is being used for advertising the unplanned or planned event with the flag. If you are advertising for some other reason today, then my question would be, if I have two implementation, sending this max metric for some private reasons, how would they interoperate today? They wouldn't. Because I can do it for reason A, the other implementation can do it for reason B. They would not interoperate because the existing specs don't specify for what reason you advertise this. We are clearly saying we are advertising this for the planned or unplanned event. What else do we need?
So that's true. I mean, you're highlighting the fact that only one use can use this.
Yes. And we are distinguishing from those. We are saying we are advertising that other purpose, quoting the spec.
Yeah, I mean, I don't think anybody has actually ever standardized a purpose for these
Yes,
things.
we do now. Yeah, I agree.
So this
I
will be
didn't
the
think we
first.
need to. Yeah, but this will be the first, exactly.
So maybe we need to make sure that if we do use it, that we leave room for type or something. I don't know.
Well, we use the prefix attribute flags. We can do any other encoding. That is not important.
Bruno, I get from your question that you think that it isn't unusable. You think it's still usable prefix. I think that's just something we have to look at the standard and figure out, right?
Well, the way I read it, you will have a reachability for a less specific prefix advertised, let's say a /24, which give you reachability for any IP prefix within that /24.
Mm-hmm.
Today, if I advertise a /32 with max metric,
Mm-hmm.
I would still have reachability with that's 32.
That's
Yeah, I
fine.
think that, yeah, that I think that's how it works.
Okay.
I mean, that's the fib. It's really, this is me and AC were talking about this, like some hardware doesn't really support black hole like routes, so this is something I think that BGP or whatever is going to be looking at and using this information to pick a new next hop. It's not actually used in the forwarding plane. I don't think it's intended to be.
It is not.
Yeah, this is all ugly. I don't understand why. I would just say advertise your prefixes, but everyone tells me I'm wrong, and there's too many.
Okay, so in summary, I think advertise state 0 is different than advertising state -1, which is what you want to do with UPA. But I guess I'm in the rough. But in all cases, thank you for the new draft.
Okay,
Sure.
let's Peter, let's move to the other unreachable.
Yep. Sure.
Asian, let me get your slides up. Thanks, Peter.
You're good to go. So here I will introduce it briefly again for our solution for the prefix unreachable announcement. Okay. This is the first time for the presentation, and we have a lot of argument in the meeting or in the list. So we move forward from the control plane, signaling, and also consideration the forwarding plane. So currently there are some other alternative solution for the discussion. Currently there are only two PA and UPA solutions are existing. So from the presentation of the last meeting, we have now the UPA redefine the and explore the LSC infinity to connect more confusion. So we are, as I have expressed, we are glad to the people have changed their proposal is similar to ours, but we think their current solution depend only on still depend on the LS infinity. So I think there are some problem for future forward. So I will explain in next slide. So here is the key point of the proposal. Some address have hide the eligibility of its current prefix. So there are over the solution, over the service need the detailed eligibility information. So we need to advertise the eligibility information for this prefix. So for our solution, upon the failure occur, so the ADR or level 1 or level 2 router can advertise the PAM message with its attached error level. So the main point for our solution is the router within the attached error level will announce their PAM capability. So there are two situations. The first is if all the node within the air support the new capability, the ADR and level 1 or level 1 to edge router just only advertise the PAM message. If not all the routers support such capability, the ADR router should advertise this message with the prefix message set to the LAC unit. We can also use other method to help the traditional node to bypass the to ignore the undefined, unknowable POM message. So such usage of the LS infinity is not changed to the original definition for its usage. So we just want the traditional node bypass the newly defined POM message if the node does not support such capability. Next. No. Oh, okay. So there are some difference for the two proposals. Our proposal for the POM message is use the existing prefix originator to sing explicitly the unreachable information. So there are already two RC to define the such prefix originator. So we just need to set this prefix originator to the no when the prefix is unreachable. There are no new flag defined, and there are no new TLV to defined. And we also consider the participation signal should be considered. There are some situations that only some of the ABR cannot reach the prefix, but other ABR can reach. So the ABR should have some mechanism to deal with such a situation. And we also consider is how to balance the reachable information under advertisement and the unreachable information under advertisement. So I think these 2 points are lacked from the UPA proposal. So this is the reason that we think the final converged proposal should based on our solution. Next slide. Okay, I think we have a lot of discussion for the problem statement and for the solution, and it's time to the for adopt the document. Okay.
Yeah, I think we've been bludgeoned, me and AC at least, into thinking that it is something the working group wants to work on. So we agree, some document needs to be adopted. It probably should be a merged solution between you and Peter. I don't think we're not gonna pick that right now, or but I think AC, do you have something to say? I do want to. I left.
Yeah. I mean,
way out of time.
Yeah. We should move on. There are differences, as both people have noted, but they have both evolved to be signaling, to signal the like for instance, one example would be the BGP prefix independent convergence. Now the difference is, the first is, this is one difference, is the first doesn't require all the routers to support it. The second does, and the second also has a secondary purpose of notifying the ABR, and it takes the other ABR and takes a different choice. So there are differences, but it would be good if you guys could at least talk and see if you could come up with a proper subset and merge the drafts. That would be good. I don't think, given the differences, I don't think we're going to either just I don't think it's a simple merge, but I'd like you guys at least to talk in the background and see what we can come up with.
And there is one more comment for the UPS solution. There is one difference between the two solutions. In the PS solution, we need the capability negotiation, but in the UPS solution, there is no explicit capability negotiation. So if we do not have the explicit capability negotiation, then the overall solution must depend on the function of the LSE infinity. I think on the contrary, we think as an operator, we think the usage of the LSE infinity should be removed later. So we shouldn't influence its usage.
No, no,
you
no,
know?
no. I think we need to take that one.
We're so out of time. It's, listen, we got like too much
we
to
gotta
go.
go.
So we gotta cut this off. OSPF adjacency suppression is, Leon in the room, or are you remote? Remote, okay.
Okay, thank you.
Yeah, 1 second, I'm gonna pass you the slides. So you select your presentation from a list. It should be showing up on your screen.
I should share the slides by myself.
Yeah, you should be able to pick your slides.
Okay, sorry.
I hate this new change.
Okay, I have to
Yes,
this.
thanks. Good.
Okay. Do I have the control to about the slides?
Yeah, you control.
Okay, thank you.
I'm gonna bring your time down. If you can try to squeeze it, it'll go a little bit faster.
Okay. This is Lian from China Mobile, and the topic I'm going to talk about is the OSPF agency surprise. And generally speaking, this draft is to avoid temporary black holes when the router is restarting from unplanned outage. And the brief introduction is as this slide shows. When the router is restarting from unplanned outage, copies of the LSA generated before its restart may exist in the LSDB of other routers. And these copies are likely to appear newer than the LSAs initially generated by the starting router. So at this situation, after the neighbors getting into the full state, it will do the root calculation using these copies. And this may cause temporary black holes to occur until the starting router originates its own ISAs with higher sequence numbers. I think this picture will help us to understand the problem well, and the main steps coding the problem is shown on the right. The first step, router A, the left router restarts from unplanned outage, and the loopback address has been deleted. The second step, the router B gets into the full state earlier. After this time, the router is calculated using the LSAs originated by A before the restart. So the loopback route, as the picture shows, the 10.1.1.1 will be reachable here until the step 4 happens. Router B receives the re-originate LSA from A. During the period between step 2 and step 4, the black holes occurs. And this problem will become more seriously, especially when B has many more LSAs than A, because the interval between the interval between step 2 and step 4 will be prolonged, because the router B will get into full state faster since it has fewer LSA to request from A. And the router A will receive self-originated LSAs and re-originate them later, since it has many LSAs to request from B. So this step will be delayed. And it's a real problem we have seen in our practical work. To resolve this problem, the key point, I think, is to change the order of the step 2 and the step 4. Following this key point, we sort out two general ideas. One is to delay step 2, and the other is to bring forward the step 4. And to delay step 2, we'll discuss 2 solutions in the following slides. The first one is that for router B, surprise advertising the agency with A, and A should send the signals to indicate this situation. And this is also our proposed solution. And the second solution is that we block the neighbor state machines through some special processing. We give an example to restart router for the restarting router to surprise DD packet with more bit unset, and we believe that is one example for the block the neighbor state machine. I think there are many other methods, but I think the result or the influence is similar. So we can discuss this later. And to bring forward step 4, after our analysis, we think that it can be treated as the second solution above. In this situation, if router B does not need to request LSS from A, so it will immediately get into the full state after finishing the DD exchange. And so in this extreme scenarios, I think it's very difficult to move it the step 4 ahead of step 2. So it's similar to the above solution 2. So we can discuss it together and skip the idea about bring forward step 4. And for the solution 1, the router B surprise advertising the agency with A, and A send SA bit to signal it through IS. The main modification is marked in red color of this picture, and the main idea is that the restart router sends hello to its neighbor router, and there are some special signals in this hello packet. Here we call it SA bit, and the neighbor router supplies the agency advertising according to this signal, and until the signal is clear, the agency advertise surprise will be released. And during this period, I think the route to from B to A is unreachable. So using this method, the black hole can be avoided.
I think we need to move to summary. Sorry, we ran out of time.
Okay, I will go fast. And this is the OSPF extension for the signals. The option 1, we can carry it in the extended options and the flex TLV, which is defined in RC 5613. And the second one is to carry it in the reverse metric TLV, which is defined in 9339. And both are okay and efficient, but we think that option A is better from the perspective of protocol compliance. Okay, next please. This is the solution 2. I will not illustrate it detailed because of the time limitation. I just emphasize the by the effect of it. just as the right characters, it will maybe it will bring more challenge to the state machine, and especially when true studying neighbor routers, maybe they will cause deadlock between them. So we did not propose this method. And for the conclusion, I think the solution 1 is proposed the solution because it's simple, no influence, and also the important reason is that it's similar to the SA bit of restart TLV in ISIS. I think it's also from the perspective of the protocol compliance. So that's all. Thank you.
Okay, I think an AC's got some alternatives, alternative solution. But that's not the one you were talking about with the option 2, I don't think. Did you have a
No, it
last
is
slide
not.
you wanted to throw up there, Leon? Like a summary slide? Okay. All right, I'll bring up ACs then, or AC, I'll pass it. Oops. And thanks, Leon. AC, you should be able to select a slide deck. Do you see that on your screen?
I see I see the former
It should be like
slides.
a list.
Oh, shoot.
Got it now? I keep passing you the control.
Okay, now I can. Yep.
Okay.
It's good. But
maybe if you can make this brief too. I don't know how we're going to get
I can. I
40
cannot
minutes and 23.
I can't see my slides though on the ones that are decks ready to be shared.
All right, I'll pick the slides. I'll share them.
Okay, next slide. Okay, this slide just says, I don't really think this problem, I'm not sure this is really a problem because once you start, once you go into exchange state, you're going to be flooding LSAs, and the restarting router will flood its router. If it has anything that needs to be black holed, that the router is going to be sending, it's going to black hole. Obviously, it's going to be coming up with other routers. So it's going to be, as soon as you go into exchange state, you're going to be flooding your LSA anyway, but that's beside the point. So I think if we were to do this, I wouldn't want to do this unconditionally. I think this solution of adding an extra handshake in here at the LLS level and complicating the state machine is worse than the problem it solves when you have an unplanned restart. Anyway, give me next slide. I'm trying to be really fast.
Right.
However, if you look at section 10.6 of RFC 2328, that's the base OSPF v2 specification, of which RFC 5340 for OSPF v3 builds upon. I added in red, now we could wordsmith this, to make sure that the neighbor of the router, when it restarts, it will it'll request the neighboring router's router LSA, even if it's less recent. If it's anything but the same instance, it's going to request it. So if the neighbor of the restarting router has a previous instance of the router LSA, that has a highest sequence number. It'll request the new one. Now you might say, what if they are the same instance, but the contents is different? Well, in the instance calculation for OSPF LSAs, the checksum's included, so that's not going to happen. Anyway, so what'll happen here, rather than allowing this black hole, is the restarting router, if the router LSA is different, I mean, the neighbor of the restarting router, if the router LSA is different, will always request it. The restarting router will send its instance, which is less recent, to its neighbor. The neighbor will immediately reply with the previous instance of the router LSA, and the restarting router will refresh it. So that'll fix this very corner case solution. And that's it. As brief as I could do it.
Yep. Okay, Leon, you're in the queue. Is it a quick comment?
Okay. Thank you, EC. First, I'm glad to hear that we got the same opinion, that it's indeed a problem in OSPF. And there are two questions about your proposed solution. One is that I noticed that you just mentioned the neighbor's router LSA. I want to see that in our slides, we just give an example about for the router LSA. And we think that for other type LSAs, for example, the external LSA is especially for the type 2, and it's also has this problem. And I think that your solution maybe cannot work for the other type LSA. And if you want to,
it works because you won't have a link in the graph between yourself and the restarting router if you don't have the bidirectional link in the graph. So you really only have to do the router LSA. I mean, unless I'm missing something, we should take this to the list given the time
Yeah,
constraints.
I don't even know. We've got 4 presentations and like 18 minutes left, right? So
Yeah.
okay, about this problem is I
Yeah,
also
we're done. We're done with this presentation. I'm sorry. I'm just wondering if we should move some of these to an interim.
Yeah. Okay, thank you, EC. We will send my question through the mailing list, and we can discuss it further.
Thank you.
Thank you.
So we don't have time. I'm sorry.
So just one question.
What?
Just one question for EC.
There's no time. I have 4 presentations to run in 18 minutes.
Okay.
They're supposed to be 10 minutes each. Yeah, please put it on the list. Okay, so route redistribution credibility ID, 5 minutes to present, please. Are you remote? Okay. I'm going to move on to IGP extensions for Link MTU. Jibo, are you present? Okay, so I will pull your slides up. Select Link MTU. Sorry, but you've only got 5 minutes, okay? Okay. Go ahead.
Hi, this is Zibo from Huawei. This patient is about IGB extension for Link MTU. Sorry, the title has something long. Next page. This job introduces how to connect network-wide link MTU through IGP extensions, and the SRPCE automatically calculates the path MTU of SR paths based on the link MTU information. Traditional MPS use SP paths establish protocol to transmit the smallest interface MTU hop by hop to the English node as the path MTU of an MPS tunnel. However, subrouting does not have establishment protocol and only special the end-to-end path as the English node. Therefore, a new mechanism is required to calculate the subrouting path MTU. This document defines a mechanism for connecting network-wide link MTU through an IGP, advise them to the SRPCE, and calculating the path MTU of SR paths. Next page, please. This page describes the subrouting path MTU scenario. Step 1, the IGP advises the link MTU. The MTU may come from configuration or verified through the padding hello mechanism. Step 2, BGP link state reports the network-wide link MTU to SRPCE. Step 3, the SRPCE calculates the SR path and the minimum link MTU of the SR path is used as the path MTU. The SR incubation cost need to be considered during the path MTU calculation. Step 4, the SRPCE delivers the SR policy path MTU to the head end through the BGP SR policy or PCP. There already have 3 jobs about SR path MTU, include BGP SR policy and PCP extensions for SR path MTU. This job mainly make up the IGP extensions for link MTU. This is about EZs and LSPF protocol extensions for link MTU. Next page. For EZs, a new sub-TLV called link MTU sub-TLV is defined for TLV 22, 23, and so on. RFC 7176 also defines a MTU sub-TLV, but it's used for the largest share probable MTU. Therefore, we don't use the share MTU sub-TLV. For OSPF, a new sub-TLV called link sub-TLV is defined in corresponding SA as special for OSPF V2 and OSPF 3. Okay, next page.
Oh, yeah, one more.
Okay. All thanks, that's all. Any question and comments are welcome.
Tony P. Juniper, making it real short. So it's a self-inflicted problem, but given it is a self-inflicted problem, I think the solution is pretty reasonable.
Okay, thank you.
Louis?
Yes, Louis Chen from Juniper. I think it's a good one, but there are 2 trouble. One trouble is how to guarantee the TRFA path also works in this case, because you have some rerouting that the MTU will change in this case. So your traffic will be affected during in the transit, right? This is the first problem. The second trouble actually is that the MTU actually is the client. So you need to signal the client to lower the MTU first before actually going to this one. That one is another trouble. I'm not sure how to address that. I'm not sure in this draft, but finally to address that problem. Okay, that's
for question 1, when we calculate the path MTU, we can consider the rerouting in calculations cost.
Okay, sorry.
Sometimes it's just transit, right? You don't know, right? The one making decision is the one in the transit node, not the head-end node, actually, right?
Okay. Yeah, I think this is worth discussing on the list more. I also, it seems weird that we haven't ever talked about doing an MTU before. It's useful info to have. I'm not sure if it's routing info, but let's keep talking about it on the list, okay? All right, thanks. So, WeMo, big TLV. Unlock. Cancel. Hang on, I gotta pull your slides up.
Hey, Chris, we
Yes.
bypassed the
I know.
the counter. Okay, you did.
I
You
know,
did that purposely.
because I asked
Okay.
for the presenter and they didn't show up. And
Oh, okay.
I didn't give them very long.
Hello, everyone. I'm Huemo Chen from FutureWay. Today, I'm going to present ISS extension for bigger TLV. Next page.
Oh, sorry. I got clock.
So basically, we'll propose a general way to support bigger TLV. So here, bigger TLV means that the folio part of a TLV is too big, bigger than 256 bytes. So we give a general way. Next page. We define a container TLV, which is a new TLV. So for any big TLV of type T, and then because it's too big, we split that one into a number of pieces. So for first piece, second piece, first piece we use normal TLV. For the rest of the piece, we use container TLVs. Next page.
Oops.
So here we give one case, which is that in a network, we have one big TLV of type T, only one. So in this case, we can split this big TLV into multiple pieces. For example, here, piece 0, piece 1, and piece n. So for the first piece, we just use normal TLV. For the rest of the piece, we use container TLVs. For example, piece 1 will be distributed in container TLV 1, and so on. Piece n will distribute in container TLV n. So in this way, originator distribute multiple TLVs, normal TLV, and n container TLV in the original site, and the receive site, we just glue that one using type T, glue everything to that big TLV. So how about the one type TLV, but we have multiple instances? That's the, we look at the next page. So in this case, for example, we have two bigger TLVs, which has same type, 22. So for first big TLV, here we just split it into two pieces, piece 0 and piece 1. So for piece 0, and then we advise that one in a normal TLV, so which is a green circle, left to right, one-to-one map. For the second piece, which is piece 1, we will distribute that one in using a container TLV. So that's on the right side. So for the second big TLV, we do the similar thing, and then piece 0 and piece 1. So in piece 0 in normal TLV, piece 1 in another container TLV. So in this case, we have a requirement, which is that TLVs for one big TLV cannot overlap or interleave with the other ones. So that's the order requirement. Next page. So in the next page, we give another option, which is that we don't have any order requirement. So in order to achieve this one, so we, in the container TLV, in addition to contain that piece, we also need to contain a key. So we'll use that key as a glue to glue all the pieces that belong to one big TLV. So here in the yellow circle, that's the key. So here we use the key as a system ID as a key. So in the container TLV, in addition to contain that piece, for example, this piece is a TLV, sub TLV K+1 to sub TLV Kn. So in addition to this piece, we also contain the ID, which is system ID. So in this case, we use that key ID to glue all the pieces belong to same big TLV. And then in this case, we don't have any order requirement. Those TLVs belong to different big TLV. They can match up in the leaf. So next page. So with this proposal, we can see that we can deploy this feature incrementally, because for the node which do not support this feature, just ignore it, just keep advertising it, I don't care. But for the node support this one, oh, I can do something and I will use it. So that's all. Thank you.
Okay. Quick comment.
Yeah, I'm pushing the button.
Just go ahead.
Yeah, Tony P. Juniper. So a couple of observations. If we had Greenfield protocol, yeah, possible solution. There is the problem is, however, we have a lot of stuff deployed in the wild. And just speaking, independent of what I'm authoring. We already have multiple copies, implementation supporting, implementation computed. So this stuff will break it, because none of this implementation will pick up, the second copy. And we will have to carry things two ways. It's just reality of the stuff, right? Contrary to the draft that is already out, where we acknowledge it. There are multiple copies and people process them. Subtle problem here, you cannot breaking in the middle on the traffic engineering stuff, because you have length fields. And if you have an old guy that will look at the stuff, the length fields will be off. So you have to start to go and fill with length fields. I don't know whether you process that, but you'll find out when you're implementing, okay? So generally, I think this is, for practical purposes, a far inferior solution to the stuff that is already standing. This is multi-TLV. Okay, thanks.
Yeah, for these two questions, I already considered that one. For the sub-TLV length field, yeah, we need to adjust that one, because when, for example, we need to adjust that one. And then regarding to already have implementation for another solution, so forget about another solution. I think that's I don't know whether it's as a working group procedure or whatever. I think in IETF, we have some guidelines or RFCs for RFCs. So we don't have those kind of protocol guidelines to, as soon as we have solution, the other solution, just forget about it.
Yeah, we know this.
But we need a multiple solution. Maybe we discuss the pros and cons, whatever, at least have some discussions, whatever, and then we can decide.
So yeah, the whole situation sucks, right? Because it's basically it wasn't standardized. People shipped a unstandardized software and basically we're stuck with it. I think that your solution, if it was greenfield and we were just starting, right, and nobody had done anything yet, using a container might have made sense. I don't think it's going to work because people already deployed the software, but we have to take this to the list. I'm so sorry. We just, no time. I got 2 presentations and 3 minutes left on my meeting.
Yeah, it's okay. Everyone can express their opinion.
We'll have to do it on the list. Yeah. Okay. 3 minutes left for advertising service functions. Hongi? Sorry if I got the name wrong. Okay.
Thank you. Okay, and I stand here to report our updates to the 2 drafts, and because Xiaohu is not able to attend this IETF, and I will represent him and our co-authors to report the updates. Next slide. And the history is that these 2 drafts were first proposed by Xiaohu in 2014 to propose some IGP extensions for SR-based SFC, and as SFC, SR-SFC is gradually experimented and deployed, and so some control plane problems will be inevitable, and there is existing BGPs that enable the distribution of topology information from the network to a controller, and BGPs for SFC currently working group draft in IDR that allows the advertisement of service functions and along their associated service segments. but we think BGPS is not completely sufficient, and we have some scenarios that require the presence of IGP. So we here revive the draft. Next slide, please. And the first use case is there are maybe some BGPS enable SFs. Also, there are BGPS able SFs. So for the SR aware SFs, if it's BGPS able, it can report the service information to the controller directly. But if it can't, so you have to use IGP to advertise their segment and service information to some proxy devices that support BGPLS and through the IGP protocol. And then the proxy device can take place of them to interact with the controller through BGPS. So LAM service function paths can be orchestrated. Next slide, please. And the second use case is that we can use BGP, use IGP to distribute SF and proxy information and to a certain device, and then we can reduce the number of BGP peers established between the network devices and the controller. And so without IGP or SF or process within the IGP area have to establish connections with the controller. So, but with IGP, it can collaborate with BGPS, and all devices in the same IGP area can advertise their topology and service information to the IBR through IGP, and then IBRs can report the information to the controller, and then the service function can be further orchestration. Next slide, please. So the first draft, it proposes OSPF extension that based on OSPF router information Omega LSA, and currently the extension contains a service function identifier, and this identifier represents a service function and within an SFC-enabled domain. And there are also some subtiers that can be extended to represent some particular attributes of a given service function. Next slide, please. And this is an example sub-tier V, and if its service function sits sub-tier V, and this sub-tier V can represent the SID and in SR, and also other subtiers can be defined to provide more service information like type and vendor information. Next slide, please. And the second draft is about ISIS extension, and this is based on ISIS router capability TLB, and there is also a service function identifier, and also some other subtiers can be extended to support more information advertisement. Okay, thank you. And next slide.
Let's get to the last one because I think you're out of time.
Oh, okay, next step, we want to refresh the draft by adding some content about the aforementioned use cases and refine some TLVs. And next, we will think about whether current BGPS drafts could have more extensions that have this cooperation. And okay, thank you. Welcome some comments and questions.
Okay, a quick question.
Yeah.
I have an attention. There are some identifier to distinguish the normal SF or the SR policy, SR proxy. Is it necessary, or it just defined by the function seed nectar and AS or and AD?
Okay, so we want to fetch less jobs. Yes, I think you said may be feasible. Yeah.
Okay, thank you.
Thank you.
Hi, Andrew Alston. Just as a question, I mean, there's been a lot of discussion around LS and, you know, whether or not it's a good idea, how we extend it, et cetera, et cetera. What I'd like to know is, why are we not looking at creating some kind of straight shim that allows for transposition of straight IGP packets almost straight into LAS in such a way that we can take the raw data in there and are not constantly trying to play with data to get it in there. Is that not potentially a better solution, just as a question?
Oh, okay. I think we may consider this.
Yeah, that's
this is
okay.
a-
That
it's
was
a good
kind of a
suggestion.
metaphysical, larger question. Yeah, I mean, basically, we're past, right? So
So, Ketan Talawlikar, Cisco, and it's already there in the base BGP-LS spec. So we could just take from IGPs and put it in there. It's already covered. So yes, it's there. I can point to the same.
I don't know. I think I took
So-
Andrew's question as to why we keep adding things to BGBLS and why we don't just have a way to just generically move it between the two. But that's a topic for a different day, not when we're running out of time. Okay, yeah, thanks. I had some comments too, but I'm going to take them to the list because we're past time. I'm sorry that I mismanaged that. I let too many people talk early on in the meeting. Sorry about that.
Okay, thank you.
Thank you. Thank you, everyone. Sorry we ran over.
Thanks, everyone.
Yeah, I was going to say, AC, you want to, yeah.
Yeah. I
Okay.
guess we could consider an interim to cover some of the things that we didn't close on, things we didn't cover and.
Yeah, if anybody, exactly, if anybody thinks that we pushed them too fast and they want to, we didn't get to all the presentations, so I got to be open to doing an interim, I think. We've got to be open to it. So just send us a note saying, I didn't get to present for the one presenter that didn't get to, or I got cut off too fast, and we can look at doing an interim.